This is the CMYX ColorMax sensor from EMX Industries. The CMYX has a 1/2 millimeter, slightly smaller than 1/2 millimeter white light source. I have the output of the sensor connected to a blue LED so that I can see when the discrete output activates. So whenever I disrupt the white light source and bring the signal down below the threshold, the blue LED turns on. Okay, and so what I've done is I looked at the background level on the piece of paper, the white paper, and it reads between 75 and 78, something like that, and I measured the level on the yellow print, and the yellow print reads 50, mid-50s or so. So what I did was I set the threshold to 60. So as I move the sensor through the yellow print, I can see I'm activating the output. Since the sensor response time is 25 microseconds, I can easily detect the yellow marks on the white paper. This is a brief demonstration of the CNTX-30-0 contrast sensor from EMX Industries. The sensor features a 3 millimeter light spot. It also features a display of the relative signal level, signal strength, over a range of 0 to 50. The sensor provides a 0 to 5 volt analog output signal that is proportional to the value displayed on the display. The discrete output on the sensor is automatically selected to operate in PNP or NPN mode, and I currently have that output tied to a blue LED, so whenever the signal level exceeds the threshold, the blue LED will turn on. The threshold can be manually adjusted by the switches on the front panel, and the response time on the sensor is 25 microseconds. So we're going to start out by looking at a very light shade of yellow. It's actually a 50% yellow on white, and then we're going to look at the difference between that and a 5% mix of red in with that 50% yellow. So right now I can see that the signal level is around 36 or 37. So what I'm going to do is adjust the threshold level so that the discrete output will turn on when the signal reaches 36. And we can see the discrete output is on and the signal is reading at 37. Now when I move into the slightly darker shade with a 5% mix of red, you can see that the signal, the discrete output turns off because the signal drops below the threshold. So fairly easy for me to set that to trigger and differentiate between that very slight shade difference in yellows. There is white, as you can see, there's white borders in between the color squares here. So as I move through the borders, the sensor is going to turn on and off. Now we're going to set up the CNTX sensor to differentiate between two very similar shades of red. The first one, slightly lighter, is a 50% mix of yellow with a 90% tint of red, and the second shade is a 50% yellow with a 100% mix of red tint. So first of all, we're going to look at the slightly lighter color, and we see that it reads 2223. So we're going to set the discrete output or the signal level to trigger at 22. So now you see the output is on and we're detecting the lighter shade. Now we'll move over to the 100% tint, and you can see that the sensor is not detecting this, so we're able to differentiate between these two shades very reliably. So think of the CNTX for your contrast sensor needs. This is a demonstration of the EMX CNTX-30-0. This sensor is a contrast sensor. It is designed to operate from around a distance of around 28 millimeters from the target surface. The display is a relative signal strength indication, and it goes from the scale of 0 through 50. The red LED indicates when the discrete output is activated. And the discrete output is connected to the green LED. So we are going to look at the contrast differences between these metallic ejector switches and a flat ejector switch. So we've set the sensor up at about 28 millimeters from the target. The high LED setting, the two decimal points indicate the high LED setting. And right now we are positioned just to the left of the arrow indicator, so in this area, and we're going to read each one of these switches. So the first one is metallic, it reads 21. The discrete output is set when the value exceeds 15, so right now discrete output is on. This is the second metallic one, quite a bit brighter, reads 34. Third metallic, similar to the second one, also reads 35. And then lastly, the flat black reads about 14 or 15, and the discrete output level, the discrete output level I believe is set at 18 or 20. So at 15 it's not activating. So we can easily see the metallic ones are easily determined by the higher reflected signal strength, and the flat again returns a relatively low signal. So that's the CNTX-30-0 sensor from EMX. This is a demonstration of the EMX model CNTX-30-0 contrast sensor from EMX Industries. The sensor features a display of 0 to 50, which indicates the strength of the reflected signal from the target. So if I block the light with my hand, the signal level goes down to 0. This is a unique application because we're setting up the sensor, the contrast sensor, at a relatively long distance, 400 millimeters, to a reflector. So right now we're getting a very strong reflected signal from the reflector, and that's registering on the sensor at a value of 50. And we set a threshold at a value of 40, and we're going to pass objects, various objects, in between the sensor and the reflector, and cause the sensor output to turn off. The sensor output NPN or PNP is connected to an LED on this little demo box. So as the LED turns on and off, that indicates that the sensor is recognizing the presence of the object, and that output would typically be connected to a PLC. So this is an opaque object, blocks all the light. The sensor reads 0, the output turns off. Here's another opaque object, a coffee cup. Again, blocks all the light, output turns off. Here is a tinted object, a soda container. You can see the reading goes very low, 0.4, well below the threshold of 40. Again, the output turns off. Here is a preform. You can see as we pass the preform through the light, the signal level goes way down and the output turns off again. Here is another preform, which is a little bit more transparent. Again, the reading goes very low, output turns off. Here is a glass, and we can see that the light passes through the glass, comes back to the sensor, and again registers very low, the output turns off. And finally, we have a container, and we're measuring through the area where there is no liquid. So it's a glass container, we're in the area where there's no liquid, and we're getting a higher reading than on the other samples, but still well below the value of 40, which is where the threshold is set. and the output is turned off. So the sensor has a response time of about 100 microseconds, so it's able to measure and output a signal very fast. If we look at, here's a glass rod. I'm going to pass the glass rod between the sensor and the reflector, so we can see the signal drops below threshold and turns off, and the glass rod is approximately 4 or 5 millimeters in diameter, and the output's very fast. Even though you don't see the display changing here, you can see the output is turning on and off as I pass the glass rod between the transmitter and the reflector. So that's a CNTX, and that is an application to detect objects moving on a conveyor, including clear or transparent objects. Here's a short demonstration of the ColorMax with the 8mm spot size and 4 discrete output channels. The samples are paint samples mounted on a clear acrylic disc here and that I can rotate. The discrete outputs are shown on the LED status indicators here, and the application software is used to program the sensor as well as see what the current color readings are from the RGB levels. So we're going to select channel 1 in the drop box. Select channel 1. Tolerance settings are currently 10%, so we're just going to leave those there. And then we're going to go ahead and program channel 1 to match the yellow sample to each ColorMax sensor. And now the yellow sample is recognized and activates channel 1 output. I've already programmed channel 2 for the white, channel 3 for the blue, and channel 4 for red. Now, the sensor does not require the software to be connected. All the settings are stored in the sensor, so whenever a blue object is in the sensor's light spot, the discrete output for that channel will activate, indicating to your PLC that color has been recognized. And again, back to white and back to yellow.